Greetings, peeps. What I'd like to do is run through how to plot your data with uncertainties. We're going to use the PyDiscs lab as a demonstration. So here's what I've done. This is a Logger Pro session. You can choose to use any program that you want to do this, but Logger Pro is available to us and it's very powerful. So here we go. What I've already done is I've down here imported a picture of the modeling equation that we're using. So in each case, physical quantities and their relationships are modeled by equations. So we've seen that. And here we know that the circumference should be related to diameter when you multiply it by pi. And so that's what our data will test, and we'll see how it works. So what I've got here is the graph in a fresh session. I'm going to immediately consider the title of the graph. We need a title for all that. Whoops. And so I go to graph options and title, and it's going to be circumference versus diameter. Circumference is the y-axis, that is the dependent variable, and diameter the independent variable on the x-axis. So I hit OK, and boom, here it is like this. Next is to create my data set. So what I'm going to do is widen this table out, and widen the data set, and fill out the x and y parts of it right now. For x, the column definition, we know that that's the diameter. The short name, d. The units, m. For meters, done. And we see it down here. What's nice is that it automatically labels the axes, which is very important for a lab report. So diameter and the units in meters. So Logger Pro is terrific. It's really good about doing these things automatically. In other programs like Excel or Google Spreadsheet, or Sheets as it might be called, you'll have to do that on your own. And we have circumference on the y-axis. We'll call that C. And the units are m. And hit done. And we'll see that it appears over here, circumference. There we are. The next thing I'm going to do actually are create additional columns for the uncertainty component of the measurement. Okay, so we have the diameter here. It doesn't work very well with plus or minus by itself, so we need a new column for that. So I'm going to go into Data, New Manual Column. Now it's going to probably stick it on the end, so we'll just rearrange the columns after. This is going to be called Diameter Uncertainty. Okay, the short name, we'll just call it DU, and the units, M. They are meters, in fact. Ooh, look at it, it said dumb. That's kind of funny. Units, M. Here we go. And DU's way over here. So in Logger Pro, you can grab the column and move it over where you want. So I'd like it next to the diameter column over here. So here's the DU, the uncertainty part. Okay. We'll do the same thing. A new, by going to Data, New Manual Column, like so. And this one is going to be circumference uncertainty. Let's get that spelled right. I want to be certain about the spelling at the very least. CU, and the units are M as well. All right, and that's in the right spot. So now I'll just widen this so we can see all of it over here. All right, diameter, DU, circumference, CU. Now what I'm going to do is input the data. I've got that stored conveniently in another spreadsheet over here on the side. I've got two screens operating just to make this quick. And so this is data that was collected in the lab, averaged out, and this is what we have. What I'm going to do, now you can see down here the data is starting to form in. I'll auto scale it, so hit the A, and there's the data. Now, what I want to do, actually, I don't want those circles there, and so I can go into options and click none, like that, and do it for circumference as well. And we got options, not an empty circle, but none. And all that's going to appear are these tiny little points. The reason is we want to see what are known as the error bars, and I'll show you how to input those next. So we double click on the header here, and in options there are error bar calculations. Now if all of them were the same, I could just choose a percentage or a fixed value, and it would use the same one for every case. But they varied a little bit in this lab, so sometimes the uncertainty went up depending on the object. So instead we have them individually mapped out over here. We're going to use column. So the columns we get to choose are between the four, and of course I'm going to choose diameter uncertainty for DU and hit done. And then I'm going to do the same thing for circumference. Go over here, double click, go to options, error bar calculations, use column, circumference uncertainty, done. And so what we have here are these cool spots where we have little I-beams that go left, right, and up, down that tell us what the uncertainty is of that measurement. So it's within that type of range. What do we do next? We want to compare this to a known range. And we're going to start with a 10% tolerance. So we're going to create a tolerance zone. Here's how we do that. In Logger Pro, you go to Analyze, Model. And the model here, I could choose linear, but proportional works because I know that the y-intercept is 0. So I'm just going to put the slope in here. I'm going to put a slope, the slope should be 3.14 and some odd digits after that for pi. Because if we look down here, c equals pi d. Well, pi is this proportionality constant, or the slope of the line. And so what we get, if we go up 10% from that, in the 10% zone range, we have 3.46 is 10% greater than the 3.14, what we would expect. So I'm hit OK, and there's the line. Okay, I'm going to set this cone up, essentially, the zone, by doing this again, Analyze, Model. And this time it's going to be 10% less. So 90% of 3.14 is 2.83 approximately. Hit OK, and this is what we get. This is the range. What we can say in an experiment is that if the uncertainties overlap and are within this cone over here, then we have good agreement with the data that it's probably a proven thing experimentally that this relationship holds true. Now, it might be possible, we're looking at this and it's well within the cone. This guy is a little bit on the fringe over here, but we might even want to consider lowering this to 5% and to find a proportionality constant or a slope that's only 5%. Okay, so this would be part of your lab report. You have the graphs, and the analysis would be essentially that, yeah, this data does correspond within the uncertainty of the measurement and within the 10% tolerance, and maybe you can go a little further and say it's possibly within the 5% or 1% tolerance as well. And so that's what it is. That's the basic procedure that we're going to use for plotting data in the lab. So we have the data tables here, and importantly the graph with the error bars and the tolerance zone to then evaluate and see, in this case, yes, the original modeling equation seems to hold true. And that's what it is. Thank you very much. Morad out.